Hello, this is Assignment 3, a machine learning challenge, and in left-hand side is my team member. So I'm gonna talk about main observation through group 1 assignment. So we obtain through the image that the highest temperature of the day have a great influence on rainfall. According to the chart, the maximum rainfall occurs during the day when the maximum temperature is between 20 and 30 degrees. So its humidity is above 70%. That's rain tomorrow 58.99% of the time. If humidity is above 90%, that's rain tomorrow 84.2% of the time. If cloud is above 7, that is rain tomorrow 25% of the time. For applied machine learning methods, we gonna use supervised learning method by apply method through the accuracy of the model, output result, recall score, and so on. So through this several curl function, the probability of the rain is predict. We will use classification predict processing outliers through classification. And the extra on the numerical feature for the subtype feature we will model to fill. According to the character and the attribute is divided in exist category, and through training and the learning of the data of no classification, the character of these different categories are found, and then the classify data in classify. Model designed to run on dataset. Describe the running process of the dataset. First, explore the characteristic of the data. Separate the feature matrix and the label Y. Explore the mixing value of the feature, then classify the label, processing the outlier, check the proportion of each outlier in the training set, and then processing data in extra amount. So just look at our right hand side to let two image. So and find out the subtype feature R, and for subtype feature we use the model to fit in, and then we just use the model in the training set to fill the training set and the test set at the same time. Deal with the continuous variable and fill in missing value, and carry on dimensionless. Apply machine learning methods. So finally carry on modeling and the evaluation, and finally through the model output. So we can see the accuracy is okay. So just look at the right hand side so you can see the testing accuracy. So actually it's okay for that. It's for accuracy, but the recall score is low, so you can see just 0.5, 0.4 or 0.3. So among these four kernel functions, the linear kernel function perform best.
Hello, I'm David, and this is my contribution to the SIT307 group project on the weather data. The purpose of this dataset is to develop a model that will determine whether or not it will rain tomorrow. Because of this, our experiments are all done with the goal of classifying the data into yes or no. My classification technique is the k nearest neighbour. Before we can develop this model, we must first select the features we'll be using to develop our model. To do this, we find correlations between the features and then test the features in the model to see how they impact accuracy. Before we go any further, we need to normalize the data. Using Pearson correlation, we can determine all the correlations between all the attributes in the data. If there is a high correlation between attributes, then 1 is not necessary and will not add much additional information to the model. And so any correlations higher than 0.9 or less than 0.9 will result in one of those features being deleted. This results in temperature 9 AM, temp 3 PM, and pressure 3 PM being dropped. Now that we had all our necessary columns, we dropped any rows that contained an NA variable that might mess with the data. We did this as we had such a large data set, we would still be left with a lot of data to work with. To determine which features we would use, we went with a forward fill feature selection, which adds features to the model and picks ones which increases the accuracy the most. We started by testing every feature with every other feature and determining the accuracies. After determining that humidity 3 pm and rain today was the best combination, we tested all the other features of these two to see which ones added the most accuracy. This continued until the accuracy no longer increased for any additional variables. The variables that all add accuracy are in order: humidity 3 pm, rain today, cloud 3 pm, humidity 9 am, wind gust speed, evaporation, min temp. The final accuracy was 82.4 using these features, but humidity 3 pm and rain today had 79% by themselves. Now, using humidity 3 pm and rain today, we want to test the most accurate K value between 1 and 100. 96 had the most accuracy with 82%, but 15 had an accuracy of 81%. With all these values, we then tested if having the weight set to uniform or distance made any difference, and it was only very minor. In conclusion, using the dataset, we would achieve an accuracy of determining if it will rain tomorrow or not, with a 4 out of 5 chance using a k-nearest neighbor algorithm, which is pretty good.
Hi, I'm Jack, and for my testing I decided to try a deep learning neural network model using Keras to predict if rain tomorrow would be a yes or a no. So the diagram in front of you visualizes how the model works. On the left you can see the variables from x1 to x15 are the inputs, and these are given different weights as they move through to layer 2. The second layer consists of 12 different nodes or neurons, which use the ReLU activation function to take the weight and turn that into an actual output that can move on to the third layer. In the third layer we have 8 nodes that use the sigmoid activation function to derive an output. Sigmoid ensures that the output is either a 0 or a 1, as in the example when we're talking about the weather and we want it to rain tomorrow, we want that to either be a yes or a no. And finally, all this gets pushed into the output, which is the y variable. In preparation to actually use a neural network, I first had to clean the weather data that we had to get rid of all the values that weren't numerical, as I didn't want to use these in my neural network and I didn't try playing around with converting them to numbers in this case. And that left us with these 15 fields, as well as the rain tomorrow field, which is the one that we're trying to figure out. Then to actually test the neural network, we have what are called epochs and batches. The batches are how we split up the data into different numbers of rows. So for example, if you have a batch of 10, the neural network will run 10 times before modifying the hidden layers that we looked at earlier in order to try and make itself better. And the epochs is the amount of times it gets run through the entire data set every time, all over again. So I tried around with doing 100 epochs with larger and smaller batches and then going all the way up to 500. I did this all CPU based, and doing epochs of around 150 took around 17 to 18 minutes, whereas when you move up to a 500 on my CPU at home, it would take up to an hour and not provide much better results. So for the example that I'm submitting, I've done epochs of 150, and this is in batches of 10, as I found that has pretty good results without taking too long to run. And finally, we took the neural network that we had just fit using the epochs from earlier, and here we got an accuracy of 83.17. Now this is when we actually ran it on the training data itself and not any new testing data. When we went and took it and actually ran it on the testing data that it hadn't ever seen before, it actually had an accuracy of 85.54. Why this accuracy was slightly higher than the model that it was actually trained on, I'm not exactly too sure, but I imagine it might be because the testing data was a much smaller amount than what the entire model was, so it may have been able to fit better on these smaller amount of numbers.
Hi, I'm Woody. My testing is to find the best parameters for the decision tree model, which also represents the factors that affect whether it will rain tomorrow or not. Decision tree is a type of supervised machine learning algorithm that can be used for prediction and classification. Here is a machine learning flowchart for the process of the decision tree. For training the model, the data column should be dropped, and any columns the data have more than 10% missing values are also should be removed. Any null categorical values are replaced with the model of the column. Numerical values are replaced with the mean of the column. The categorical value should be encoded into numerical form. Finally, all the values are normalized. And to find the best parameters for the decision tree model, grid search and cross-validation was used. And here's the result of the grid search. Then training decision tree model, there will be ROC curve and confusion matrix chart will be generated in order to evaluate the performance of the model. From the model, the best 10 features based on importance are humidity 3 p.m., wind gas speed, rainfall, humidity 9 a.m., mean temperature, wind direction 3 p.m., wind gas direction, temperature 9 a.m., location, and wind direction 9 a.m.